Our first study in the forms of lines is going to be the slope-intercept form, which, as I've said before, is the most useful because it tells us the most direct information about the line. And so these equations have the form y equals mx plus b, which, just to review, means y equals m times x, because that's multiplication, m times x plus b, where m is the slope and b is the y-intercept. The y-intercept is where it crosses the y-axis. So if you have, if you have your axes here, and here's x and here's y, and here's your line going this way, then the y-intercept is going to be this position right here. Is going to be that position right there because it's where it crosses over the y-axis. And then again, the y-axis is this line right here. Okay, so it's where it crosses over the y-axis. You know you have slope-intercept form because y is isolated on the left. Or rather, it doesn't matter if it's on the left or the right, but it's isolated on one side of the equal sign, and that's the only thing on that side of the equal sign. And when you have that, then the coefficient on the x, is the slope, and then the constant over to its side is the y-intercept. So, and we've talked about this. We've done this in the inquiry activity with the bank. The slope represents the change. So the slope represents the change in y over the change in x, which is, like I've said before, is y2 minus y1 over x2 minus x1 for any 2 points, x1, y1, and x2, y2. But if we think about this, this is the change in y over the change in x. So this is saying how much does it go up in the y value or down for every unit in the x value. Okay, and so we saw this in the bank example where we were going along like this, and our x-axis was the turn number, or essentially time, the time that passes. And so each time that passes, each turn that we take, the number was going up by a certain amount. And so essentially what we're asking here with the slope is how much dollars are we going up every time we go out this way one turn. And so that's where you get the rise over the run. So it's saying how much dollars per time are we getting? How many dollars per turn do we get? And so the dollars are the rise and the turn is the run. And so that is why it is the change in y going up over the change in x. Okay? So now that we've reviewed that, let's look at some examples. Okay, so here's one. I'm actually going to zoom in a little bit. Just zoom in here so we can see this. Okay. Y equals 7/2 x minus 2. Well, the 7/2 is the slope, because if we think about this, this is literally y equals mx plus b. So here's the m, right? I'm going to do the m in blue. The m is right here. It's the number that's multiplied to the x, and then the b, is this, is going to be in green. The b is this minus 2 right here. So you notice it's plus b, but we're subtracting 2, so the b is actually a negative 2. So in this case, m is a positive 7/2, and b is a minus 2. Okay, so if we're actually trying to do this, we have to first plot the y-intercept because you got to know where your starting point is, right? There's a lot of different lines that could have a slope of 7/2, but only one of them is also going to have a y-intercept of -2. So the y-intercept of -2 is right here. So that is the first point on our line. That's the blue point, or excuse me, the green point, -2, and it's on the y-axis. And now the slope we're going to count out is 7/2. So again, this is rise over run, okay? Rise over run. So we have to rise up 7. So if we rise up 7, we're going to be at a +5, and then we have to run 2, so our blue point is going to be there. That's the point that directly comes off of it from the slope. And so now that we have 2 points, of course, we just have to connect with our trusty little ruler and draw it in. And so there is the line whose equation is y equals 7/2 x minus 2. That's the line. Okay, let's look at a different one. Right here, y equals -6x plus 3. Well, in this case, again, this is y equals mx plus b, right? So the m is -6. It's the coefficient on the x. So the m is -6, and the b is +3. So we have an m of -6 and a b of 3. And you're probably going, oh, well, great. If my m is just an integer, how am I going to turn that into a rise over run that I can count out? Well, don't forget that any integer is itself divided by 1. So the slope here is -6, which is the same as saying -6/1. So if we count out our intercept first, b of 3, a +3 would put us right there. And then we're counting out. Again, this is rise over run. Okay, oops, I'm off the screen there. Rise over run, so our rise is -6. That means we're going down 6. So we have to go down 6. 1, 2, 3, 4, 5, 6. So we're at -3. And our run is still a +1. Remember, it's a -6. So there's a few ways we can write -6. Remember that -6 is the same as -6/1 is the same as 6/1. And you can do either of these. It'll still work, okay? If we had done a rise of +6, we would be going up and over 1 and 1 in the negative direction, but we're not doing that. We're going down 6 and running 1 in the positive direction, so we'd be here. If we had gone with this slope, we would have ended up over here, but if you notice, they're still on the same line. If I had drawn that in the right spot, it would still be on the same line. Right? Because there's an infinite number of different points on the same line. So here we have our 2 points, we just connect them, and boom, there's our line. Just like that. So that's -6x plus 3. You can also have something that looks kind of weird like this, y equals -5. But what I want you to think about, what's the coefficient on x here? Well, there is no x, so the coefficient is 0. So really, this is the same thing as saying y equals 0x minus 5, right? Because 0x would just be 0, and so we just literally have y equals -5 then, which is exactly what we have here. So our slope is right here, that's m, and our b is right here. So nothing has changed. Okay, so the m is 0, or excuse me, the b is -5, and it has 0 slope. So b is -5, so we're down here at the -5 for the intercept. Now the m is 0, so let's think about this. So m equals 0. Remember on slope dude, 0 fun? Well, remember, this is the same thing. This could be 0 over 2. This could be 0 over anything. It'll still be 0. So the rise is 0, and the run is however many we want, because that could be anything, right? So we're not rising up at all, but we're running as far as we want. So we could end up here, or here, or here. It doesn't matter, or even over here. Any on this kind of latitude there. They're all on the same line. And notice that that is indeed, going by slope dude, that is indeed a slope with 0 fun, right? 0 fun. And I don't really know why my line went all crazy over here. Let me get rid of that. Alright, so that's a 0 fun line, right? Okay, so here we go. Our m is right there, and our b is right here. This is an easy one. B is plus 1, and m is 6/5. Now, if we were to go up, because our rise would be 6, right? Just think about this. So m is 6/5 is the rise over the run, right? So if we're trying to rise up 6, we're going to go clean off the graph, because if we're already at 1 and we're rising up 6, we're going to be up here at 7. And I don't want you to just sketch it in and try to graph it. I want you to go the other direction. So remember that 6/5, positive 6/5, is the same as negative 6 over negative 5, right? So we can actually turn this into something. Again, this is still the rise over the run, but in this case we're going down for the rise and negative in the run also. So our negative rise is going to take us down 6. So that's going to take us down to negative 5. And our run of negative 5 is going to take us out here to negative 5. So there is our other point. Now notice, if I had actually gone up 6 and over 5, both in the positive, I would have been up here and over here. And notice I'm still on the same line, right? Because I connect them and they're still on the same line. So it really doesn't matter which one I do, but just for the sake of being more precise, I am going to ask you not to go off the chart. If I give you one where it goes off the graphing, what I intend for you to do is then go to the other point and not go off the graph. Okay? Let's do one like this. Let's do one like this. Right here. 2x plus 5. Well, again, the m is 2 and the b is plus 5, and of course with an m of 2, that's saying 2 over 1, so there's our rise over run, so our b is 5, and our rise of 2 is going to put us off the graph, so we just have to again think about this as a minus 2 over a minus 1, and so in that case we're going to go down 2 and to the left 1, and so there's our negative point there. Notice, but even though we're going all negatives, it still gives us a positive slope, right? Because negative divided by negative is positive, so we expect it to be a positive slope. So there's that. And I want to show you how to do one more thing. These lines are in standard form. If you notice, this is standard form, which we haven't learned about. But basically, if we have to just solve this and turn it into slope-intercept form, write the slope-intercept form like the directions say here, all you have to do is treat this like a literal equation and solve it for y. So if I want to isolate the y, I need to get this positive 3x off of here. So what I would do is, of course, I'm going to subtract the 3x to get it away from there because I don't want it over there. So then those cancel, and I'm left with a negative 2y equals negative 3x minus 16. Notice that I took the 3x and I shoved it in right there in the front, because in the mx plus b, the x term always comes first, and so that's just the way we're more used to looking at it. So I would recommend getting in the habit of writing the x term first, because it'll help you visualize what's about to happen. And now, of course, I need to get rid of the negative 2. So I divide everything by minus 2, and that by minus 2, and that by minus 2. And these go away, and I'm left with a y. Negative 3 over negative 2 leaves me with a positive 3/2 x. And notice, and here the negative 16 over negative 2 leaves me with a positive 8. And so here is the slope-intercept form of that same line we started with, without cutting off the 3 right there. But I want you to notice something here. Let's look at this, because I wrote it a little bit differently, and I want you to see something. So negative 3 over negative 2x is the same as negative 3x over negative 2, is the same as 3x over 2, or is the same as 3/2 x. All of these things are the same thing, because if you think about what's happening here, this is being multiplied, right? That's being multiplied. It's saying 3/2 times x, but x is x over 1. So if I multiply these fractions here, top and bottom, the top is just 3x and the bottom is just 2. So you can think about these as the same thing. You can think of 3/2 x as the same as 3 over 2 times x. Those are exactly equivalent, and sometimes it's beneficial to think about this, and sometimes it's beneficial to think about this.